Physics. Yes, we have completed chapter number 3, 4, 5 and 6. Today we will start chapter number 2. Title is Units and Measurement. Chapter title is Unit and Measurement. So yes, first of all, question, what is unit? How to take measurements? But before that, yes, in this all chapters we have discussed about numbers of physical quantities. Numbers of physical quantities. So what is physical quantity? What is physical quantity? See, if we want to study any system, any object, then we have to find its properties. For example, if we want to study this classroom, we have to find its properties, means what is L, that is length, what is B, that is breadth, what is H, that is height. Then from that we have to find its volume, that is equal to it is LBH. Okay, so yes, if we want to study any system, any object, we have to find some properties related to that object, related to that system. Okay, if you want to study me, okay, then yes, if you want to study a person, then you have to find his height, his mass, okay, his color, etc, etc, etc. So this height, mass, color, so these are properties related to that person, related to that object. So in physics we have to deal with numbers of physical quantities. Physical quantities means it is property of object. It is property. It is property of object. Okay, so yes, in physics there are numbers of physical quantities. Yes, path length, displacement, average velocity, average speed, velocity, acceleration, force, work, kinetic energy, potential energy, power. Yes, there are numbers of physical quantities that we have discussed, and another physical quantity we will discuss. Okay, so yes, in physics we have to deal with numbers of physical quantities. Yes, measurement of any physical quantity. How to measure any physical quantity? Measurement of any physical quantity involves comparison with certain basic internationally accepted reference standard. What is meaning of this? See, one simple. If it is one line, and if you want to find length of this line, and if you want to find length of this line, yes, how to find length of this line? Obviously with the help of scale. You have to put scale like this. Okay, suppose length of scale is 30 centimeter, then it is 30, then it is again 30, and then it is again 30. So what is length of this line? It is 90 centimeter. So see here, measurement of this line involves comparison with some internationally accepted reference standard. Yes or no? Yes. Okay. So measurement of any physical quantity involves comparison with certain basic internationally accepted reference standard, and it is called unit. So what is definition of unit? See, measurement of any physical quantity involves comparison with certain basic internationally accepted internationally accepted reference standard called unit. It is definition of unit. Now we will understand each and everything. See, measurement of any physical quantity involves comparison. Yes, how to measure length. Okay, so you have to compare that length with scale. With scale, yes or no? You have to compare that length with scale. Or if I want to find mass, then how to find mass? How to measure mass? If you know that simple balance, one side we have to put known mass, okay, that is below of that aluminum, okay, and another side you have to put object. When that simple pendulum, when that simple balance is in balance condition, we can say it is that much amount of mass. Okay, so yes, any measurement of physical quantity involves comparison with certain basic internationally accepted reference standard. Internationally accepted reference standard means if in India 1 centimeter means this distance, then in any country 1 centimeter means this distance. So that is meaning of internationally accepted. That is meaning of internationally accepted. If in India length of unit is meter, then in any country in the world length of unit is meter. Length of unit is meter. Okay. So yes, it is definition of unit. Okay. Measurement of any physical quantity involves comparison with certain basic internationally accepted reference standard called unit. Okay, now how to write any physical quantity? How to write physical quantity? How to write any physical quantity? Okay, see, if you want to write any physical quantity, for example, first scalar, then how to write scalar quantities? If I say what is mass of a person, then mass of a person, okay, if I say my mass is 55, then is that numerical value 55 enough to describe mass? No, we have to write some internationally accepted reference standard, that is mass m is equal to 55 kg. Mass m is equal to 55 kg. So yes, mass, it is physical quantity. Mass is physical quantity. Okay, any physical quantity is expressed as 55 means it is numerical value. It is numerical value, and this kg means it is unit. This kg means it is unit. So how to write any physical quantity which is scalar? That physical quantity is equal to numerical value into unit. Numerical value into unit. Clear about this? Clear about this? Okay, mass is equal to 55 kg. Time t is equal to, it is 8 hours. Yes or no? Time t is equal to, it is 8 hours. Length l is equal to, it is 50 meter. Okay. Distance t is equal to 100 kilometer. Yes or no? Yes. So yes, how to write any physical quantity for scalar. Now for vector, how to write any physical quantity if it is vector. If it is vector. For example, we have velocity. Then velocity v is equal to, it is 10 I caret meter per second. 10 I caret meter per second. So yes, it is physical quantity. It is physical quantity is equal to 10. That is numerical value. That is numerical value. What is I caret? I caret, that indicates direction. It indicates direction. Or we can say unit vector. It is unit vector. And meter per second is unit. Clear about this? Clear about this? So yes, it is how to write any physical quantity. It is how to write any physical quantity. Clear about this? So again, we will repeat these points. Physical quantities means it is property of object. Unit, measurement of any physical quantity involves comparison with certain basic internationally accepted reference standard called unit. How to write any physical quantity? Scalar and vector. Scalar, numerical value and unit. Vector, numerical value, direction and unit. Okay. Now, out of numbers of physical quantities, there is certain group of quantities. Okay, and such quantities, they are called fundamental quantities or base quantities. Okay, out of large number of physical quantities, a certain group of physical quantities is called fundamental or base quantities. Fundamental or base quantities. Okay, and yes, units of such fundamental quantities or base quantities are called. Okay, units are called base units. The units are called base units. Clear about this? So yes, in physics we have to deal with numbers of physical quantities. But out of these physical quantities, a certain group of physical quantities is called fundamental or base quantities, and their units are called base units. Now, time to time, they have accepted some group of quantities as fundamental quantities, and they form one system of units. So, different system of units that have accepted till now. Okay, so yes, system of units. Again, time to time. Okay, by different scientists, they have formed some basic group of quantities called system of units. So yes, according to base units of some physical quantities, see, first it is CGS system. CGS system. C means it is for centimeter. G means it is for gram, and S means it is for second. So in CGS system, they considered three quantities as fundamental quantities. They considered three quantities as fundamental quantities. Which one? Centimeter, that is unit of length. Gram, that is unit of mass. And second, that is unit of time. So yes, in CGS system, they considered length, mass and time as fundamental quantities, and their units, they considered centimeter, gram and second. That's why in short form it is called CGS system. Again, in CGS system, three fundamental quantities, length, mass and time, and their units centimeter, gram and second. Next system, that is FPS system, or we can also say FPS system, that is British system. So in FPS system, F, foot, here it is pound, and here it is cycle. Again in FPS system, foot, pound and second. Foot, that is unit of length. Yes, it is unit of length. Pound is unit of mass, and yes, second is unit of time. It is unit of time. So again, see, numbers of fundamental quantities and fundamental quantities, that is length, mass and time, they are same. but their units are different. But their units are, okay. So first system of units, that is CGS system. Second, that is FPS system. Next system of units is, yes, it is third one, that is MKS system. That is MKS system. Here M stands for meter, K stands for kilogram, and again S stands for second. Okay, so again in MKS system there are three fundamental quantities: length, mass, and time. But their units are different. Clear? So till now, CGS, FPS, MKS, different system of units they have considered. Right now, at present, we use SI, that is System International. That is one system of units. Clear about this? So yes, right now we are using this System International, SI system. We are using SI system. And yes, in this SI system, there are 7 base of fundamental quantities. There are some 7 base and fundamental quantities, and another quantities. They are derived quantities. Now, what is meaning of derived quantities? A quantity which is represented as combination of fundamental quantities. A quantity which is represented as combination of fundamental quantities is called derived quantity. Okay. What is derived quantity? A quantity represented by combination of a quantity represented by combination of base quantities is called derived quantity. Clear about this? So now in this chapter we will study in detail about this SI system. In this chapter now we will study in detail about this SI system. Clear about this? Okay? See. Now we will see SI system in detail. Okay, in SI system, 7 quantities are considered as base quantities, fundamental quantities. Yes, you have to remember these 7 base quantities, their units, and how to indicate or how to denote their symbol. See, here it is. Physical quantity, unit, and it is symbol of unit. Okay, first physical quantity is length, and its unit is meter, which is denoted by symbol small m. Always meter is indicated by small m. Meter unit is indicated by symbol small m. Okay. Second physical quantity is mass. Its SI unit is kilogram. Its SI unit is kilogram, which is indicated by small k, small g, like this, kg, like this, kg. Okay. Third one is time. Its unit is second. Its unit is second, and it is indicated by s. It is indicated by s. Okay. Fourth physical quantity in SI system is electric current. Is electric current. Okay. Its unit is ampere. It is ampere, and its symbol is capital A. Its symbol is capital A. Okay. Next one is number 5. That is thermodynamic temperature. That is thermodynamic temperature. Okay, and its unit is Kelvin. Its unit is Kelvin. It is indicated by K. It is indicated by K. Clear about this? Next one is number 6. Next one is number 6. That is amount of substance. Its unit is mole. Its unit is mole, and it is indicated by MO. Okay. Last one is that is luminous intensity. Luminous intensity. Its unit is candela. Its unit is candela, and its symbol is C. Clear about this? So yes, you have to remember this table. Yes, in SI system there are 7 base or fundamental quantities. First quantity, length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. Their units are respectively meter, kilogram, second, ampere, Kelvin, mole, and candela. And how to write their symbol? Unit, symbol of units. Small m, that is for meter, kg, that is for kilogram, small s, that is for second, capital A, that is for ampere, capital K, that is for Kelvin, mole, C. Yes, see, when we write unit, we have to take some care. How? Unit of meter is small m, but why unit of ampere is capital A? Why unit of Kelvin is capital K? Why unit of force is capital N? Because some units they are denoted after the name of scientist. Ampere, it is name of scientist. Kelvin, it is name of scientist. Newton, it is name of scientist. So whenever units which are derived from name of scientist, they are in capital letters. They are in capital letters. Clear about this? So yes, first of all, you have to remember this 7 physical quantities, their unit and their symbol. Their symbol. In SI system, unit of length is meter. In SI system, unit of mass is kilogram. In SI system, unit of time is second, etc., etc., etc. Clear about this? Okay. Now, derived quantities. Now, derived quantities. What is derived quantity? See, we will take one example. Speed. What is speed? Speed is equal to, we know that it is distance upon time. What is speed? Yes, speed is equal to, it is distance upon time. Distance means length. It is base quantity. It is base quantity. Time, it is also base quantity. It is also base quantity. Yes or no? Yes, it is. Speed is equal to distance upon time. Distance, that is time, is base quantity, and time is also base quantity. So yes, we can say speed is combination of 2 base quantities. That's why this speed is called derived quantity. It is called derived. Clear about this? The speed is called derived quantity. Now, how to find its unit? It is simple. How to find unit? Unit of speed. Unit of speed is equal to unit of distance, unit of distance upon unit of time. So what is unit of speed? What is unit of distance? Here it is unit. This length means it is distance. Okay, and yes, its unit is it is meter. What is unit of time? It is second. It is second. So yes, what is unit of speed? It is meter per second. Or you can also write meter second. Meter second. Clear about this? Clear about this? So yes, this speed is derived quantity, and this meter per second, it is called, this meter per second, it is called derived unit. It is called derived unit. Clear about this? So yes, you have to remember 7 base quantities, fundamental quantities, and what is meaning of derived quantity and derived unit. Okay, we will take another example. See, we will take another example. Acceleration. Acceleration is equal to, what is acceleration? Yes, acceleration is equal to, it is velocity upon time. Acceleration is equal to, it is velocity upon time. What is velocity? Acceleration is equal to velocity upon time. What is velocity? Yes, we know what is velocity, students. Yes, velocity is equal to displacement upon time. Velocity is equal to displacement upon time. So yes, I can write acceleration. Acceleration is equal to displacement upon time. Okay, and divided by, yes, here it is time. So we can write is equal to, it is displacement upon time square. Upon time square. Clear about this? Okay. Acceleration is equal to velocity upon time. So acceleration is equal to, velocity means displacement upon time divided by time. Now displacement. Displacement means nothing but shortest distance, that you know. Displacement means shortest distance. Distance between initial and final position. So yes, its unit is meter. And what is unit of time? It is second. But here it is time square. So second square. Or you can also write this unit as meter second is to minus 2. Meter second is to minus 2. Clear about this? Okay. So yes, again this acceleration is called derived quantity. It is called derived quantity. And this meter per second square, it is called derived unit. It is called derived unit. Clear about this? So yes, in this lecture we have discussed about what is physical quantity, what is unit, how to write any physical quantity, system of units, then SI system that is used presently. Okay, SI system. In SI system, 7 base quantities, then numbers of derived quantities, and yes, in next lecture we will study 2 supplementary quantities, that is plane angle and solid angle. But yes, up to this derived quantity, this is it for today.